Okay. So this section is about the same as we had with the exponentials. Sometimes you'll be able to equate the logs together, and if you have two logs that are supposed to be equal, then the stuff inside the logs have to be equal, right? And then sometimes you have to do the changing. You need to use that fancy formula that we have from the very beginning. So for this first one, right, we're going to use some of our logarithm rules, just like before. When we're using our exponent rules, we can use those to combine stuff and make it a little simpler, so that way when we change it, it's not too hard on us to solve it. Same thing here. We can use our logarithm rules to combine stuff, right? So those two can combine into log of 3x minus 2 divided by 2. And what we use there is log of m over n is log of m minus log of n. Basically, you get to subtract two logs, right? We're using it in the backwards direction. We're going this way, okay? And this is equal to, whoa. My tablet's acting screwy. Okay. Log base x, or sorry, log of x plus 4. Since we have logarithms that are equal, right, then the stuff inside them has to be equal. So then 3x minus 2 over 2 has to equal x plus 4 times 2 on both sides. 3x minus 2 is equal to 2x plus 8 plus 2 plus 2 minus 2x minus 2x. X is equal to 10. We're done. Got it? Something like these. So notice we have a log equal to something without a log. So here's where we use our handy little conversion from before, right? So it goes a to the b is equal to c. That is converted into log base a of c is equal to b, right? So initially, for the last couple problems, we've been going that way, right? Now we get to go the other way. Got it? So this case, it'd be, so here's our A, here's our B, and this in here is our C. So this to that power has to be equal to that. So 2 squared is equal to x squared minus x minus 2. This just so happens to be x squared minus x minus 2 is equal to 4. What I'm going to do now is plus 4, or sorry, minus 4, x squared minus x minus 6 is equal to 0. This has a nice split. X minus 3, x plus 2. So my two answers are x is equal to 3 and x is equal to minus 2. And we are done. It seems manageable for people. Not
Yeah.
bad, right? Okay. I'm going to do the breakout thing again. So what I'm going to do now is why? Okay. So come on. There we go. Okay. I hadn't chosen problems for this. Well, like I said, I put up an old version of it, not knowing that it didn't have the problem set up. So I wrote up some new problems for people to try out. And again, same thing. Does everybody have these problems now? I hope so. Okay. I'll make the changes to the packet that's online shortly. But in the meantime, just write these down. I'm going to break you guys up into your groups again so you guys can solve the problem that pertains to you guys. Okay. Let's try this. So I see you guys haven't joined your groups. I think who's in here? I've heard Miguel before, but Michelle and Libby I know have had issues with connectivity. I know Libby doesn't have a mic. So at least you guys should be able to discuss stuff over chat if possible. Okay. I do want you guys to try it. I do want you guys to attempt it. Okay. In the meantime, I'm going to go check another group.
Julio.
More sense.
Julio.
I mean, if we're wrong, we're wrong.
I like that.
Okay.
Julio. Is that a log base A or is that a log base 9?
Log base 9. Log base 9.
Oh, that is 9. Okay, so
That
it's a
is
9 and an A?
Yep.
Okay.
Wait, how do you do it then?
Yeah, how do you do it then?
No, so both of them are log base 9.
Oh.
That looks like an A. Okay.
It's a straight up A, Julio.
I'm sorry. I try. Let me see. Let me go.
I'm looking at your live notes right now, and I'm like,
Yeah. Let me
And it's also a plus too. How do we get a?
Yeah, how's that different?
Because we can't really.
No, I'm saying like how would you do it different? If you just
There, how's that?
It hasn't updated yet.
Okay.
It takes a second to update, but yeah. One of these days.
One of these days. Why I oughta one of these days.
So would it be okay? That guy, it's a 9. So those both turn into 1. So it's x minus 5 plus x plus 3 equals 1. Is that a 5?
That
Would
is
you-
a 5. Oh,
Okay.
Would you multiply them together? Like x minus 5 times x plus 3?
right, that's the rule.
So it is this a foil?
Mhm.
Yeah.
Okay.
Try it out.
X squared plus 3x minus 5x minus 15.
Our third
Equals-
person still in DMV. Damn.
Yeah.
Yeah. Okay, I'm gonna go terrorize another group. You guys.
We're stumped on this one.
Which one is it?
Number 3.
Number 3. Let's see, number 3. Oh.
We're not sure if we need to put the 2 back on the exponent or if we divide both sides by 2.
Ah. I think dividing by 2 would be the nicest thing to do.
Yes.
Yeah.
That's what
Because putting the 2 back into the exponent,
mm-hmm.
that's going to make it much more difficult.
Okay. So then it would be 10 to the 8th equals 7x plus 6.
Right.
Oh man. Okay.
And in this case, you want to keep 10 to the 8 as 10 to the 8. Don't write.
Oh. Okay.
I think that's what, 100 million? Don't write 100 million.
Yeah,
Just leave
don't-
it as 10 to the 8.
Okay, so 10 to the 8 minus 6.
Yeah. Got it?
Yes.
Okay. We'll go bug another group.
Thank you. 7.
These guys. You guys. Yay or nay? Okay, I think I'm going to call people back.
I guess you're just gonna yoink us.
Yeah.
We're still doing the problem.
Keep trying.
Mm-hmm. 3, 4.
All right, you guys ready? For the most part. Okay. So, the first one is pretty straightforward. So, I'm actually just going to do the first one and the third one. That's great. I'm going to do this first one and
And
this
we
third.
can't see your screen, by the way.
Oh, okay. Yeah. Let me change that. Okay. So we're going to use our multiplication rule, right? So this is going to be log of x minus 1. Since we have two logs and they're equal to each other, the x times the x minus 1 and it has to equal the 4x, right? So x squared minus x is equal to 4x. X squared minus 5x is equal to 0. Our two answers are and we're done with that one. Okay, the next one I want to do, and I think I'm going to skip the next example.
Wait, can you do 2 actually?
You want me to do 2?
Yeah, I'm a little stuck.
Okay, so let's do 2. So same thing happens here. Actually, you know what? I'm going to do just 1 and 2 because I do want to move along. I've already spent like 2 hours on this one.
Okay.
That's okay.
So same thing, we can combine them, right? So log of 9, log base 9 of x minus 5, x plus 3, both of those things together is equal to 1. Now we can use our conversion, right? So x minus 5 and that is a 9, not an a. So x squared minus 2x minus 15 is equal to 9. X squared minus 2x minus 24 is equal to 0. So can we do this?
I'm trying it right now.
Okay.
-6 and 4.
Right.
Yeah.
So my two answers.
8 of 4. Okay. I skipped a step. Okay.
Yeah,
Thank you for clarifying.
sometimes it's the skipping of one step that kind of provides you the insight for what to do next.
Mm-hmm.
So if you need the space, if you need to write it down, if you think you need to write it down, just write it down.
Mm-hmm.
Okay. Like I said, I've already spent a bit too long on this. What I want to do now is so actually I'll do, let me see, because after this it's lecture questions, right?
Yes.
Yeah, lecture questions. Okay. So what I want to do is, no, I'm going to leave it. I'm going to let you guys do the lecture questions. I'm going to skip this.
Oh.
Because I actually want you guys to practice with it. So I'm going to give you guys maybe 20 minutes to try out the lecture questions. Yeah. How are people doing with it?
So you signed video assignments during the week of spring break or no? Yeah.
I think well, I don't remember. I think I did.
Yeah.
Well, like I said, I think you might need to use a late pass on them if you don't get to them over the spring break, but they're only 10 questions, well, 5 questions long each.
Oh, okay.
Okay. I'll be right back. How people doing?
I'm actually stuck on the very first one.
How so?
So would you subtract 6 from both sides?
Right?
And then would you just put it in log form and leave it like that? Oh, okay.
In this case, you're gonna take you're gonna do the ln, right? Because the base is
Yeah. Yeah.
Yep.
So ln 38 equals negative 3k, and then just solve for k.
Yep.
Okay.
So isn't it hurricane weather in Florida right now, Dana?
Not until June.
Oh, okay.
Pretty good right now.
Yeah.
It's fucking hot though. I'm sweating.
Yeah.
On my break, I jumped in the pool. So
Yeah.
so rough.
Yeah. You have it just so difficult right now.
It is. I'm social distancing myself.
Yeah. Entirely the other corner of the continent.
I am. Well, he lives in a neighborhood that there's no one around. Like he lives on a couple acres of land, and there's no one around. So
Oh, so, yeah.
So I'm in the middle
of nowhere, essentially.
Well, I mean, I can walk down the street and go to Daytona Beach, but
yeah, but it's closed.
It's there's people there.
Really?
They don't care. They don't care.
Yeah, they don't.
And then, like I said, the spring breakers, they got kicked off the beach.
Yeah.
Some of them did. Well, all of them did. So if you look out on the water, they just went to all the boat rental places and rented boats.
Wow.
So they're out in the middle of the water.
Yeah, not out in the middle of the water. Wow. Well,
getting drunk.
Well, I mean, it's spring break.
Yeah, they're not going to be stopped.
Yeah. Definitely not going to get stopped.
Well, there's a lot of them. There's a lot of them here.
Yeah, that's unfortunate. Hopefully nothing horrible happens, but if it does, it's going to be one of those I told you so's.
Yeah. I don't know.
Yeah.
Hopefully this shit hopefully this shit dies down.
Yeah. I mean, I think everybody's hoping for it now. Nobody's had to do something like this like ever. Like
yeah.
So people are getting a little fed up. So that's understandable.
Well, Trump wants to open America back up because he's losing money.
Yep, I heard that.
So we'll see how that goes.
We shall see.
Got a quick question.
Yep.
So is the third question the LN one?
Yeah.
I got the answer x equals 0 and x equals positive 10.
Mm-hmm.
Okay.
Yep.
Okay.
Do you know where we could find the compound interest formula?
So that's one of the examples I didn't cover.
Oh.
So let me get rid of the. Where's my pen? There it is. It's actually behind the K. There we go. So am I still sharing?
PT? Yeah.
Yes.
Yeah. So it's this formula right here.
Okay, the PT.
So
Can we just
maybe
input everything?
yeah. So let me write in what the R, the N are supposed to be. So P is the initial investment or initial amount.
Mhm.
R is the rate, right? It has to be in decimal.
Oh, percent rate.
And then the N is the number of compounds. So if you compound it semi-annually, that is 2 times a year. If you compound it monthly, that's 12 times a year. Got it?
Got it. Thank you.
Huh? Yay! Such a pretty day outside. Never mind, it got gloomy.
That's the perfect day.
Wow,
I
so dark. So dark.
like gloomy.
Really?
Yeah.
I've got to see the sun every once in a while.
Too hot.
Nah.
Uh,
So after we plug everything in, how would we have to use a log to solve it?
Yep. So it's asking you how many years until your investment is worth 40 grand, right?
Uh-huh.
So the 40 grand is going to go outside, right, where PFT is, because you want the entire investment to be equal to that, right?
Yeah.
Is equal to the 6,500
Mm-hmm.
times compounded quarterly. So 1.0, well, sorry, 1 plus 0.0725 divided by 4 to the 4t, right?
Yeah. Yeah.
So do the same thing that we were doing for the original problems, the exponent problems, not those. These, right?
Okay.
Specifically,
So,
actually, this one, right? Something like that.
uh-huh. And then just solve for t?
Yep, you're solving for t in this case.
So first we would divide by the 6,500?
Yep.
Okay. And should we round to the nearest 100?
Yep.
Okay.
So 2 decimal places is enough.
Okay. Okay.
where's my calculator?
So it so would it be log oh wait. We actually have to divide the 0.0725 divided by 4.
Fuck do I get back there?
Huh?
So how the fuck do I get back there?
Get back where?
Oh, back to this thing.
Oh.
You know, I went back in there.
It must be muggy over there.
Yeah. No, kind of. Yeah, it's muggy. I'm not gonna lie.
Yeah.
I was trying to justify it, but you can't.
Yeah. Last year in October, I went to Hawaii, and I went for a conference, so I had to go pretty well dressed.
Yeah.
That was a mistake.
I've never been to Hawaii.
It is so nice.
I tried for many years to tell the Army to send me to Hawaii, and they said no.
Darn it.
Every time I put in the request,
Yeah.
it got rejected within like 24 hours.
Really?
Yeah, they said no.
Wow.
Every time.
Yeah.
And I even called the Department of the Army where
Yeah.
they do all the relocations and stuff.
Yeah.
And they said, Sergeant Roach, your track history proves that you're not gonna make it in Hawaii. I was like, oh, all right. I was like, why? They're like, you like to party. And I was like, oh.
Darn it.
They said you can go to Korea though. And I was like, all right, fuck it, let's go to Korea.
Yeah.
There's no partying in Korea.
Yeah, sure there isn't.
Oh no, there's a lot of partying in Korea.
Oh, I know.
They didn't know.
Yeah.
I was in Korea for I did 3 tours in Korea.
Oh, wow.
I kept them, I went back and then I just go back to Arizona and I volunteered to go back to Korea. Like, this place is fun.
Yeah.
Because I put an extension the first time in 98.
Yeah.
I got sent to Korea. And then I put an extension in and they denied it. And they sent me to Arizona. And I was in Arizona for 6 months. And I put a request to go back. And they approved it.
Huh.
I was like, so why'd you guys, I was already there. You could have just, like, oh.
Yeah.
So, pretty crazy.
Yeah. All right. You guys ready to move on?
No.
I'm still on the first one on the deposit thing. So, are you supposed to take out the 1 and put the other side after you divide it the 6,500?
You don't move the 1, so you have to
Oh, okay.
sort of simplify that stuff inside the parentheses,
Mm-hmm.
right? Simplify it down to 2, maybe 3 decimal points,
Okay.
so that you can get a base. .725 divided by 4. So it'd be and 2 decimal places, right? Yep.
Okay.
Okay. We need to keep them moving.
And then from here, you change it to a log?
Yep.
Okay. Oh, then it's okay.
Yeah. Okay. So I need to move on. I need to. I want to finish up chapter 4 before we move on. At least finish up chapter 4 so that when we come back from spring break, we can start chapter 5, which is new stuff, absolutely new stuff. Because I'm pretty sure you guys are getting tired of logs and polynomials and this and that.
Didn't Ren and Stimpy sing about logs?
Huh?
Didn't Ren and Stimpy sing about logs?
What's next? We start trigonometry next. And that starts with angles. So it's going to start easy, and it's going to get lots and lots harder. So what have people been doing on the lockdown?
Driving?
Still working.
Playing games.
Playing video games? Yeah. I gave in yesterday, I think, and I ended up starting to play a video game. Where do you work, Edlin?
I work at Wells Fargo, so it's an essential business. So we are open.
Essential business, you have to go. Yeah.
But honestly, I can't really complain because a lot of people aren't working, so I'm pretty lucky.
Yeah. I mean, you know, the first of the month is coming up. I'm hoping my landlord says, "Yeah, don't worry about the rent for this month."
Yeah, we're all hoping that. But
Yeah.
you never know.
Feeling it's not going to happen. So.
Not in California.
Yeah.
What's that?
Huh?
Was he? What'd they say about that whole tax thing? They're gonna send a check for like $1,200.
Yep, $1,200 per person.
But I guess they're gonna like if you filed your taxes already, they're gonna
Tax you from them? Wow.
they're gonna direct deposit it or something.
Really? Wow. Huh.
Something like that.
Oh, that's not that bad, actually. So, well, I haven't done my taxes yet. I was actually going to be done this next trip that I was going to do and to my parents' house, and didn't materialize. Thanks, coronavirus.
I was just reading about that Chinaman who they said, I don't know if it's a hoax, but he died of a different hantavirus.
Yeah, these viruses need to get in line one by one, please.
I guess he was, I don't know.
Yeah.
And the doctors are hoarding some kind of medicine.
Really?
Yeah.
Wow.
But Trump says just go in the sun and you'll be okay.
Just listen to him speak and we'll all be all right.
You know, I feel there's nothing anybody can do. I don't like the guy, but
yeah,
there's, I don't know. No matter what he does, someone's going to say something.
Yeah.
I think that they just got to stop arguing with each other and just figure this shit out.
Yeah, and I think everybody's working as quick as possible. So at this point, we're only waiting for somebody to say, yep, we've got it.
Yeah.
Do you keep it as a log or do you actually solve it?
So, you're talking about the bank one, right?
Yeah.
Positive money. Solve it out. You can do it with your calculator.
I don't know where that is.
You don't know where your calculator is?
I don't know. I cleaned my room, so
Oh.
I don't know where I put it.
Well, whenever you do, punch it in.
Okay.
Yeah?
Mm-hmm.
All right. I'm going to move on. But it's not too different from things that we've already been doing. I keep on saying that, and you know, nobody believes me. But this, for sure, is exactly the stuff that we've been doing. We're just going to put them into, we're going to put some applications behind them. That's it. Okay? So this section deals with exponential and logarithmic models. There's specific ones that I want to cover. They need, actually all of these are exponential models. So we're going to need the logarithm to get rid of the exponent, right, to solve stuff. So there's 3 of them that I'm going to cover today. The first one being just the exponential growth model. Okay. Exponential growth model deals with, you use it to figure out how things grow exponentially. Usually things that grow or reproduce do so exponentially. Okay. So this is used very commonly in biology. It's used in, it's actually what's being used for the coronavirus to map it out. At least one of the equations. It's used in population growth, all this stuff, okay? The equation itself is that one in green, okay? Each one does specific stuff again, okay? The A naught is what we call the initial amount. The T is the time. The K is the growth or decay factor. And there's something nice and special about the K. If it's bigger than 0, it's a growth. We know that it is a growth. And if it's less than 0, it's the decay. And the A of T is the final amount. Got it? Okay, so we have a scenario here, for example, 1, where it doubles every hour, right? So for most of these, so I'm going to write this equation again. T is equal to A0 E to the K T. The goal in life for nearly all of these problems that have an exponential growth is finding that K. So that's exactly what we're going to do. We have a couple things that we can fill in already, right? So we need to find a model that, an equation that models the exponential growth. So we need to fill in basically everything from our equation that's right here, right? So we can fill in a bunch of stuff already, at least some of the stuff, right? So A naught, we know we're starting with 10 cultures, right? E to the K T. And there is, now we get to use that doubles every hour. So we know that this is true. So we know that after 1 hour, it must double. So now we get to solve this thing, right? So divided by 10, divided by 10. 2 is equal to e to the k. And here is where we do ln of 2 is equal to k. So, and if we type in ln of 2 into our calculators, we get let me pull out my calculator. What? 0.693. So our equation now is 10e to the 0.693 t. And we are done. There is our model. Got it? It was nice and short. Okay. There's a specific type of exponential growth or decay that we use in chemistry, and it's called the half-life. Usually when you have radioactive stuff, that stuff releases radiation, and after a certain amount of time, because it's released so much radiation, it becomes half of what it was. Hence the word half-life. Hence why we call it half-life. Okay, the way that we find half-life is that thing right there. Got it? So, for example 2, the half-life of carbon is 5,730 years. Express the amount of carbon remaining as a function of time. So, if we have, so in this case, if we know our half-life, it can give us our K pretty easily. Okay, so we know our half-life is 5730, which is also equal to negative ln of 2 over k, which implies that our k is negative ln of 2 divided by 5730. So if we type that in, whoa, 0, 0, 0, 1209. So we have our K, which means our A of T equation is some A naught, which is our initial amount, E to the 0.0001209 T. So if A naught so depending on how much we have as an initial, right? Whoops. We have 10 grams of it. 0.0001209 T. And we are done. This is our final answer. How are people doing with this stuff? I haven't heard much besides a siren.
All right.
Not bad for now?
I actually had a question on the calculator.
Okay.
So when I put in ln2 divided by 5730,
Yeah.
I got like an E -4. Is that just like move the decimal 4 places?
Right. So you got 1.209 and stuff.
Mm-hmm.
Let me actually write it how it shows up on your calculator. E to the -4, right?
Yeah.
So that means grab your decimal. Negative means it moves this way. 1, 2, 3, 4 spots. So now my decimal's there, and you fill in zeros.
Okay. All right. Just wanted to verify. I wasn't too sure.
Got it?
Yes. Thank you.
So now, radiocarbon dating. So if you guys ever do something in anthropology, this is what's widely used in anthropology to date stuff, if it's sort of recent enough. So it turns out everybody, all bones have a certain amount of carbon in them. Depending on how old the bone is, you can find out how old, depending on how much carbon is left inside the bone, you can tell how old that bone is. This is common in anthropology. So if people find bone fragments and they think if it's an old an old human ancestor, they take it to the lab, they find out how much carbon's left in it, they know how much carbon's supposed to be in it, and they do the math that way. And that's how they find out if you have a bone that's 10,000 years old. So what I'm going to do here, so on example 3, we have something sort of similar to that, right? So a bone fragment is found to contain 20% of its original carbon-14, right? How old is the bone? We have a nice model for it from up here, right? All we got to do now is to account for that 20%. So if originally, right, it had 100 grams, 20% is how many grams? How much? It's found to contain 20.
80?
Not 80.
I don't know.
So 20 is left.
Mm-hmm.
So you have to have 20 grams left, right?
Yeah.
So 80% or 80 grams have left the bone, right? So we're going to use the model from up above, right? The only difference is we're going to change that A naught. So A of T is equal to, let me write down the base equation, E to the 0.0001209 T. Now we can fill in the rest. We know that this bone had 20 grams left. So 20 is equal to 100 E to the 0.0001209 T. Now we solve for T. Divided by 100, divided by 100. Move it up here. 1/5 is equal to E to the 0.0001209 T. Here's where we use our ln. So ln of 1/5 is equal to 0.0001209 T divided by so T is ln of 1/5 divided by 0.0001209, which is and that did I forget? Aha. So in the equation above in example 2, I forgot a negative. So make sure you add the negative in. How's that look to people? So our final answer is right here. Blocked out a little bit. So using what we just did, right? The bone is about 13,000 years old. Have I broke people yet? Are people on spring break mode already?
Broken.
Broken. I knew it. How? Where? What? Why?
I can't get my calculator to work, so.
That's okay. I mean, does the work before the use of the calculator? So you need the calculator
To do that, yeah, but the work before is okay.
Yeah. So
It's just getting that final number.
right, just getting the final number, that's fine. But you get everything before that, right?
Yeah.
Okay. So that means I didn't break you.
I'm about to throw my calculator though.
Well, yeah, I bet.
Or maybe it's the tequila. I don't know. It could be the tequila.
Could be. It could be.
It might be.
Yeah.
Hey, it's 3 o'clock here. It's okay.
Oh yeah, that's right.
So don't think I don't have a problem yet.
Yeah.
Maybe if I was in California.
Yeah. All right. Next one. Newton's law of heating and Newton's law of cooling. So technically these are two rules in one. You see this a lot in physics. If you ever need to heat something up or cool something down, right? We use this equation right here to determine what temperature it's going to be at after a certain given time. So just like the other ones, there's specific values that we need to fill in, right? So the T is always going to be the time. The A is going to be the difference between the initial temperature and the surroundings. So practically, it's sort of to reiterate or say it in better words, right? The temperature there's going to be a difference between the temperature inside the oven and the temperature outside the oven. A is that difference, however many degrees difference that is. So if the inside of your oven is let's say 300 degrees, right? And the outside of your oven is 75 degrees, that's a 225 degree difference, right? So that'd be A. And then K, this is a constant that belongs to each object. Okay, same thing as the problems before. We needed to find the K. Same thing here. We're going to go ahead and find that K for this, and then we can find temperatures for at a given time. So in this case, we have a cheesecake that's taken out of the oven that has an internal temperature of 165, and it's placed into the refrigerator that's at 35 degrees. After 10 minutes, it cools to 150. How long until the cake cools to 70 degrees Fahrenheit? Okay, so same thing. We still have to find that K, which is exactly what we're going to do. But we're going to fill in some stuff first. So A is going to be the difference. So this is the inside of the oven, and this is the fridge, right? So we can consider that the outside of the oven. So 165 minus 35 is, I believe, 120?
130.
Or 130, there you go. Oh yeah, 30. Cool. Okay. One thing I missed up here. TS is the surrounding temperature, so this is outside the oven. So we can fill in a bunch of stuff already. Whoa. So A of T is going to be 130 E to the KT plus 35. So we're getting closer. We still have to find this K value that's right here, right? And that's where we're going to use, after 10 minutes, the cheesecake has cooled to 150. So we know that it's going to cool to 150. So 150 is equal to 130 E to the K times 10 plus 35. Notice that all that we have now to solve The only thing that doesn't have a value attached to it is the k. So we start doing our math. Minus 35, minus 35. That is 115. That's 115. 130 e to the k 10. I'm going to go up here. Uh, 115. So at this point, I'm going to do divided by 130. 130. Those go. So 115 divided by 130, what does that reduce to?
.88.
It's going to be 23 over.
Oh, you want to do that way?
Yeah, I'd rather have it simplified.
All right.
I mean, it's equivalent, and we don't have to mess with nasty decimals. Is equal to e k times 10.
And that's when you do your.
Right, this is where I do the logarithm. So ln of 23 over 26 is equal to k times 10 divided by 10 divided by 10 k.
Yeah, and then my calculator is broken, so.
23 divided by 26. And that divided by 10. So I got negative 0.0123. So that was the important thing. We needed that k, right? So T of t, the temperature of t at a time t, is the 130 e, the negative 0.0123 t plus 35. So this down here being negative, is it a growth or a decay?
Decay.
Right. Does it make sense in terms of the problem?
Yes, because it's cooling down. So.
It's cooling down, so it's got to be decaying, right? So all is well in the world. We haven't broken anything yet, right? So now, the final question was, how long till the cake cools to 70 degrees Fahrenheit?
So it would just.
What do we do?
Replace the T with 70.
Right, the big T, right?
Yeah.
70 is 130, right? E to the minus 0.0123 T plus 35 minus 35 minus 35. So that's going to be 35 is 130 E 3T divide by 130, divide by 130. Divided by 5, So this is going to be 7 over 26 is equal to E negative 0.0123 T.
Ugh.
I know.
ln 7 over 26.
Right?
And then equals E, yeah.
Divide by 0.0123. Negative. So I'm going to write it over here. T is ln of 7 over 26 which is you guys notice that this is going to be the last time we meet until after spring break. So I haven't seen you guys since what, 2 weeks ago, huh?
Yeah.
So this is going to be 106.68. So will be whoa. So what is about an hour and 40 minutes?
Yeah.
Right? And there's our final answer right there. Actually, I mean, I didn't write in the units. How are people feeling with it?
Good.
I'm going to skip the quick check. I want to do this one. This one's actually going to take a little long. Well, hopefully not too much longer, but.
You really want to talk about the flu?
Yeah. So this is the graph. This form of exponential growth is the one that is governing the reasons why we're making the decisions that we are for the coronavirus.
Right.
This is the equation that's doing it. So about 2 weeks ago, so I give you guys a graph of the function itself. So this is the equation. This is not the equation for the coronavirus. This is the equation for just this problem for the influenza problem, but it still has all the good stuff in it. So a logistic growth equation looks like this. So usually one person is sick, right? And that one person, if you put them all into a room of, let's say, 1,000 people, right? Eventually, all 1,000 people will be sick. And it'll grow in an exponential manner until it hits that 1,000 people. So about 2 weeks ago, the US was down here. And I think people noticed that it's about right around here where you guys can see that growth, it starts to climb really heavy. And it turns out it was about here where we decided to do some social distancing. So the idea behind the social distancing is, so the example that I have here is for 1,000 cases, thinking that we're in a room full of 1,000 people, right? We're hoping that because of the social distancing, that number will hopefully come down lower and lower and lower. So that instead of our graph, instead of the number of cases of the coronavirus climbing all the way up there, we sort of just climb up to here and sort of level off. That's what we're gunning for. And all of that is governed by the logistic growth model. Okay, so suppose that we have, let me actually explain the function itself first. There's 3 things there that we need to define. This value, C plus 1 over A, is the initial value. Just that C value is the carrying capacity, or the limiting value. Usually what limits the growth, okay? And this B value is what's called the growth rate, and that's usually particular for every problem. So we're going to do a case study for influenza, for the flu at LMC Brentwood. Okay, suppose there's 1,000 people at Brentwood on any given day. So our function itself won't grow, or the number of people that have influenza won't grow past 1,000, right? The growth rate for this particular strain of influenza is 0.6030, right? So at this point, it becomes a plug and chug. Got it? The only problem is we still need to find that A. So we're going to find the model for it now. So our C, like it says, it's the carrying capacity. We can't go past 1,000 cases in a day. Got it? So what we'll have is this. F of X is equal to the 1,000, 1 plus A e to the B, which is given there, 0.6030 to the T. Now, there's an added piece of information that f of 0 is 1. So we're going to plug that in, and hopefully that'll pop out our A. So if we do that, 1 is equal to 1,000 divided by 1 plus A e to the 0.0603 times 0. 1,000, 1 plus A e to the 0. What's anything to the 0 power?
0.
1.
1.
So we have this now going on, right? 1 this thing right here is equal to 1. And if we solve this out, we get A is equal to 999. Now we have a decent enough model to do something with it. So f of x is equal to the 1,001 plus 999 e to the 0.6030 t. So here we have our model. So now the question is, how many people will have the flu after 10 days? What does that tell me to do?
Plug in 10.
Right. Actually, let me change. So I've been using X's and T's back and forth. I'm going to keep it as X's. I'm going to change all the T's back to X's. So then we're trying to find f of 10, right?
Isn't B supposed to be negative?
Are we growing or are we decaying here?
Growing.
I'm just going because of the picture up there.
Right. So if we're growing, what does that B need to be?
Positive.
Positive.
Oh, okay.
So no matter what, we can still use the logic from way up here, from these two, right? If that exponent right there, if that k exponent right there is bigger than 0, we're growing. If it's less than, we're decaying. Got it? Oh, not too far. E to the 0.6030 times 10. And that's something. So 6.030. Oh, something went wrong there. I know. This is one of the things that's best done on a calculator. Oh, okay. Net times. Something's going wrong here. 0.0636030. Okay, I think I might need to check this problem because something's going wrong. Are people there?
Mhm.
Yeah.
So everybody should be getting like a decimal number for 10 days, which is incorrect.
If you make the B negative, you get 293.85.
Hmm. You are correct. I think I see what you mean. So
Yeah, because right there where it says figure 7, it says
Yeah.
the graph of and the B is a negative.
yeah. Well,
Under the graph, there's a
Yeah.
formula.
is everybody still looking at my screen?
Mhm.
The B, there's a negative innately in front of.
That's what he was saying earlier.
Yeah, that's what he was saying earlier. Yeah. So the negative comes innately from the formula itself, from the logistic growth, but you can still use the logic that since B is positive, then it is grown. So negatives all over the place. So negative here, negative there. Oh my God, can you believe that? Everything else is still okay though. But now I can compute this and get a correct number. Okay. And that times 1. Come on. My phone's acting up now. So you should get 1,000 divided by 3 point. Somebody's putting hearts. Aw. So if you do that right, now we should get, there you go, 293.85, which is about 294. Now this works out, thank goodness. Does that make sense?
Mhm.
Okay. And then last question,
The hearts.
the hearts, I know. How many people will have the flu as time goes to infinity? So if we let this thing go on, how many people should be infected with the flu?
1,000.
1,000.
1,000, right? And hence the reason why this is up here, right? So if at Brentwood, there's no more than 1,000 people on campus in a given day, right? It can't grow past 1,000. Hence the reason why it's called the limiting factor, the limiting capacity. We can't go past that value. Ooh, that hurt. Dana.
I'm right there.
How'd you do that?
I can make hearts too.
Oh, that's you with the hearts?
I don't know. I went to view options,
Yeah.
then go to annotate.
In Zoom?
Yeah. Well, on your So when it says you're
Ah.
viewing Julio your screen, you go to view options, annotate, and then you get a text bar. You can put hi.
Oh, you could put hearts in there and just copy paste that everywhere. Oh, that's
Yeah.
cool.
And then the arrow, you can just go like that and be like, pew.
Wow. That is
Or you
pretty
can put a question mark.
Yeah, I know you can annotate. So like, and this goes for everybody, that you can draw stuff on my screen.
You can make some cool
This can
arrows.
go out of hand.
This can get out of hand quickly, but I should probably disable it. No, I'm gonna keep it. I mean, you guys are in college. I'm pretty sure nobody's gonna draw something inappropriate,
No.
right?
Good thing class is over, huh?
Yeah. Yeah, I've seen people bet and making the professor leave. Wow. Well, I hope that doesn't happen.
Yeah.
But I mean, so what I can do, yeah, we can delete all of them. I can hear Dana erasing it all right now. You're gonna turn this into anatomy class, huh?
That's pretty cool.
Yeah, it's useful. Some of the students in my statistics class, they tend to point stuff out.
Okay, you can even have a mouse. Yeah. Yeah.
So that, and then same thing, I can erase stuff.
Yeah.
All right. I didn't get as far as I wanted to, but that's okay. We finished chapter 4.
Yay.
Yay. Very much so. Very much yay. So, we'll come back after spring break. Spring break is next week, so just keep that in mind.
All next week?
All of next week, yeah.
Okay.
So we ended up not moving the spring break. We actually ended up having it at the same time. Let me see. And let me get to my calendar really quick. There we go. All of spring break will be the 30th, basically next week. From the 30th to the 3rd, we should be meeting back up on April 6th. Will be our next meeting time. I think I set them up.
Yeah, you set them up through spring break, so I was like,
ignore them.
okay.
Yeah. I'll be, yeah, yay. I'll be online no matter what up until Friday. If you guys need to talk to me over spring break, that's fine too. Just send me an email. We'll work something out. Yeah. We'll figure out the rest when we come back. The assignments are up for the lecture questions as well.
You just take a picture of them, right? And then send it to you?
Yep.
Okay.
So I think everything, I made everything due, I think, after spring break. If not, I'll move them again. I really just threw them up there because I didn't know I hadn't put them up there yet. So if I do need to move them again, send me any questions that you have or any comments, and I'll change them.
They're due this Saturday.
Do this Saturday? No. Okay, so I need to change those. Because that's a lot of modules for you guys to do. And they're closed. Yeah.
It says all Saturday and then like some next week, Monday, Tuesday.
Yeah.
Yeah.
So I'll change the ones for chapter 4 so that they'll be sorted out. Some of them are closed. Which ones are closed?
Closed. I don't see any closed.
I think video assignments 1, 2, and 3.
They're closed?
I'm pretty sure, yeah.
Okay. So I'm going to change that right now.
Oh, yeah, they are.
They are? Okay. I'm going to change that right now. In the meantime, class is done. I shall see everybody. I hope to see everyone. Hopefully, we will all see each other in class, in our classrooms on April 6th. I doubt it, but I hope so.
Are you gonna email us if we aren't?
Yes, the district is still discussing about what to do.
Okay.
I believe our our final date of the stay-at-home order was going to be April 6th, I think, statewide. For the district, I think it was going to be also April 6th. So we should hear before then whether or not we are going to meet or not.
Okay.
So yeah, in the meantime, I'm going to go change those due dates now.
And unclose them.
And unclose them, yeah. Let me see.
All right, see you guys later.
Okay. Have fun in Florida. Stay
yeah.
safe. Wash your hands. Have fun.
Yeah.
Hey, guys.
Yeah, you guess. All right, who's left? Let's see. Aha. Mohammed, I'm going to end the meeting. I'll be in my office later on today, my office, my virtual office. So if you need to ask me a question, I think my lab hours start 1:15 to 2 today. And it'll go on till maybe around 4 o'clock. I think I have office hours directly after that for a little bit. No, 3 o'clock, sorry. So if you have any more questions, ask me there, okay? Okay. Besides that, I'll change the dates and I'll hopefully see you guys after spring break. Okay?